Okay, welcome to Scholars Guild. I'm going to make a few announcements. There are refreshments in the back. Thank you, David Reese, for bringing goodies for us and some drinks back there. So help yourself. There's a sign-in sheet. Most people are signing in as they come in, but if you've missed it, try to sign in before you leave. Also, there's a basket for donations. They go to the Arden Club. There's also some cards like this that have a QR code on the back for the Arden Club. If anybody here has not become a member, you might grab a card and you can get right in and sign up to be a Arden Club member. I want to also thank David Gerbeck, who's up in the controls and technology. And I want to thank Chris Day, who does setup. I don't know where he is right now, but next month, November 18th, we have Abigail Quant. Does anybody want to, Alan's not here, so she is the Senior Conservator Emeritus from the Walters Art Museum in Baltimore, Maryland. And she's going to talk about the role of conservation in reading the lost words of Archimedes and Galen. So that should be really interesting. That is November 18th. Our statement of respect for the Scholars Guild, we are dedicated to inclusivity and justice. We ask all comments be cognizant of racial and gender equality and be sensitive to the diverse identities of our audience members. Thank you. At this point, I would like to introduce our speaker. This is Dr. Gregory Dobler from the University of Delaware. He's at the Biden School of Public Policy and Administration, the Department of Physics and Astronomy, and the Data Science Institute of the university. He is an urban data scientist whose research focuses on studying cities as complex systems. He wears a lot of hats. So he brings all these together to analyze different areas. He is the director of the Urban Observatory Facility at the University of Delaware, as well as New York University. And I just asked him, he goes to New York frequently. Professor Dobler applies data analysis from multiple sources to including AI, to investigate city skylines, noting air quality, energy consumption, lighting technology, public health, and sustainability. He also has worked with governmental agencies on the equitable distribution of green spaces, measuring traffic safety also, and models of how infectious diseases spread. Tonight, he's going to turn to AI. He says he's going to bring it down to a level that I can understand. And if he does that, then I know that any of you are safe. His title is From Code to Consequences, the Role of AI Regulation in Our Lives. And he would like it if you'd hold your questions till the end, unless you have a burning question, and then you can ask during his talk. Please welcome Dr. Dobler.
All right. Thank you so much. It is wonderful to be here with you all. This is really exciting. This is really great. Yeah, so as you just heard, my background is kind of all over the place. So a little bit about maybe some framing for what you're about to hear. So a long time ago, I got my degree in physics, and then I was a practicing astrophysicist for about 10 years. And then I decided I wanted to do something different with my life. And so I took kind of a 90-degree turn and I started studying cities. I went to NYU to a center there called the Center for Urban Science and Progress, where the sort of mission of the place was to study cities from a sort of data point of view, because there was a lot of data coming out of New York City, which we'll talk about. But then also to sort of use that data and use an understanding that you might get about an urban system to solve actual real world problems. And so we would like partner with city agencies to like address issues they may have had. As you just heard, I did work with like equitable distribution of green spaces and stuff like that. And so that, that got me sort of at the intersection of, that like technology and data and AI, and as you'll hear in a minute, machine learning and all that. And the policy space. And so 6 years ago, the University of Delaware created a data science institute, and they came knocking. And so I came down here, and then that's the rest is history. So to give you a sense, again, to put kind of, maybe some background expectations on what you're about to see. I just came from class. The class, so sorry if I'm a little hoarse, but the class that I just got done teaching is called Data Science Tools for Evidence-Based Policy. So like, what are the kind of sort of analytic tools that folks might need in order to understand situations from a data perspective in a way to inform decision making. And then I teach another class called Machine Learning for Public Policy, which is focused more on the sort of AI side. And in both of those classes, I try to like bridge students who come from like a highly technical background, but don't have a lot of understanding about how things sort of fit within society, and students who have a lot of understanding about society, but relatively little technical background. And so sort of putting those two things together to sort of create this like harmonious center kind of thing, right? So that's where we're coming from. All right, so I'm going to get started now. I'm going to try to hold the microphone, but I shake my hands around a lot. So I'll try to keep it by my face as much as possible. Okay, so, right. So there's a couple of stories that are going to be sort of interwoven into the talk tonight. On the one hand, we're going to talk about AI and how it sort of intersects society. And in particular, how we might think about putting our arms around that and putting guardrails on that and putting rules of the road that might guide AI moving forward in a way that is beneficial to us all. In a parallel track, because my belief is that in order to do that, and I'll show examples of why I think this is the case. In order to do that, I think having an understanding of what AI is, how it comes to be, and how it does what it does is sort of central to that piece of how do we make regulation about AI that might actually stick? Okay, so to that end, the story begins with this up here, which this hieroglyphic looking thing is called a neuron. So a neuron is not like the neurons in your brain. This is a mathematical construct, this sort of picture here. And the idea is that this neuron thing eats data. It takes in data. What kind of data might it take in? So let's say that I picked a random person in this room and I said, what is your age? So that might be one piece of data that the neuron takes. Another one might be, what is your height? Right? However one might want to give that to me. And then a third one might be something like, how many years of high school basketball did you play? Where that number could also be 0, right? And the job of a neuron, we'll talk a bit about how this works later, the job of a neuron is to take those 3 numbers and mash them together and spit out another number. which is the probability of you being able to dunk a basketball, right? So this is what a neuron does. What happens inside the circle doesn't matter too much, but it takes in data and spits out a number. Okay, so that's a neuron. Neuron was sort of first talked about in this context, in the sort of data context, was first talked about back in 1943. So it's quite old, but we'll talk about why it's so relevant now and why it's become so relevant so quickly now. All right, so here's another one that's maybe a bit more policy relevant. If I was to take a person and ask for their credit history and their annual income and the highest degree they have obtained, a neuron could mash up those three numbers and spit out a number, which is like the probability of that person defaulting on a mortgage. And that kind of thing is exactly what banks do when they try to assess whether or not to give you a mortgage loan, right? And so a neuron is just this thing that can do that. It can mash together numbers and spit out another number, okay? That's all it does. So these three numbers are okay, yeah? What if I had said that these three numbers are the ones I wanted to use instead? So that's not allowed, right? Race is what's called a protected class under current US law. And race cannot be used as an input to any kind of mathematical model, including a neuron, that might predict whether or not you're going to default on a mortgage. You can't make mortgage decisions based on race in America right now. That was not always true. I encourage you to look up the history of redlining in America, for example. Okay. All right. So, but this kind of thing shows potentially, and we'll get a lot more into this in a minute, this kind of thing shows how regulation, how law can impact the way that something like a mathematical model, like a neuron, might function. And it's at this level, I think, that we have to be thinking about these things. Because unless you are, these mathematical models can be very slippery in terms of how they get used. Okay. All right. So let's keep moving. So that is a neuron. Now, a neuron, it was quickly realized that neurons were sort of not quite powerful enough as a mathematical model to be very generalizable. Just because, you know, this might work for one person on whether or not they could dunk a basketball, that same model might not work very well for another person. So maybe we need two neurons. If we have 100 people, maybe we need a bunch of neurons. And so quickly, people started taking these neurons and stitching them together, where the output of one neuron would sort of point to the input of another neuron, and kind of meshing them together like this. And that's what's called a neural network. Okay? But the same basic principle applies. You have data coming in one side, and now it's not just one neuron that's sort of doing the magic. It's a bunch of neurons working together that are trying to do the magic. And so the only real thing to take away from this is that we've made the model more complex now. It's not just one thing anymore. Now it's getting more complex. And it's getting, frankly, a little bit harder to sort of understand. We'll talk about that in a minute. Now, it doesn't just have to be that. Neural networks can get very complex indeed. You can start adding lots of neurons until they start to look like a web of arrows pointing all over the place. Still, the same basic principle applies. Data comes in, number gets spit out at the end. But they become, with this complexity, a lot more generalizable and a lot more powerful in terms of being able to predict things for multiple people, whether or not they can dunk a basketball, for example, or whether or not this person is going to default on a mortgage. All right? You can also not only go like this way, but you can go that way too, and you get what's called a deep neural network. So a deep neural network just basically means like there's a bunch of neurons that keep pointing to each other for a really long time. And I know it looks confusing right now, but some of the biggest AI models right now have billions of neurons in them, and so become incredibly complex. That actually has a lot of consequences, which we'll talk about. All right. So that's called a deep neural network. And in a minute, you're going to forget everything I just said. But the idea is, once you have this kind of complexity, it's no longer just about asking like, oh, I take a few numbers and I see what can come out. You can take data that's incredibly rich in its own complexity, like a picture, which has a lot in it, hand it off to a neural network like this, and it might spit out 4 things instead of just one. The probability that what you just handed it is a human, a picture of a human, a probability that it's a picture of a tree, probability it's a picture of a car, probability it's a picture of a cat. And the idea is that neural network will say the probability that that picture is a tree is higher than the other probabilities. So that now I could close my eyes and hand it a picture of something I've never seen before, and it will tell me that's a cat. Right? And you may say, oh, well, why is that useful? And we'll see why that's useful in just a few minutes. Okay? But this is the basic idea. You have a spindle, and this is the reason I started here is because those neurons, they really like the cells, they are the building blocks of every AI that you have ever interacted with or anybody that you know has ever interacted with. That's a sort of generalized statement. I'll point out where that's not exactly true in a minute. But to very close approximation, that's true. And those cells get built up into ever more complex models that can take ever more complex data and make predictions that are more and more accurate about what that data is or what that data means. Okay. So let's chop those off for a second. So that thing that's in the middle, that structure, that deep neural network, that is an AI model. So I'm going to move from neural network terminology to model technology. That's a model. It's a mathematical model. And in fact, we can even draw a little box around it and say, the thing that's in that box is really complicated. I don't understand it. And I'm not alone, because for many of these models, they are what are referred to as black box models, which means that it is almost impossible to understand, even almost mathematically, how a piece of data travels through that model to give you a prediction at the end. That's certainly true for very complicated neural networks. Now, that said, there are some AI models that are not the most prominent models right now that are a bit more explainable, that are a bit more understandable. I'm not going to talk about those. Certainly the most common ones right now are these neural network models that essentially they act as black boxes. You pass in data goes through the model, outputs some prediction. And that picture right there is all of artificial intelligence, more or less. Those models are really complicated, and there's like thousands of computer science papers and papers in other disciplines that try to build out new complexity inside that black box to do new and ever amazing things, which I'll show you examples of later, of course, right? But at its core, that is what an AI is. It's what it does. Okay. Okay, so there's a couple different kinds of AI. I'm speaking broadly here. Not only is the terminology vastly changing, but there's new stuff coming out all the time. But if I'm putting things into very broad categories, there's basically 2 kinds of AI at the moment. What's referred to as predictive AI and generative AI. Okay. So what's the difference between these 2 things? I'm going to give you the Wikipedia definitions of these. So predictive AI is an artificial intelligence model that is fed new data to develop an understanding of its environment, capabilities, and limitations. What that basically means is it's kind of like what I just showed you. You feed it some data, it makes a prediction about something. Can they dunk a basketball? Are they going to default on a mortgage? Is that a picture of a tree? It's predicting something, right? And then there's generative AI, which uses generative models. I know that's kind of like a circular description. It uses generative models to produce images, video, audio, software code, or other forms of data. It's generating new data, essentially. Okay, so predictive AI takes in a picture and predicts, I think that's a bike. Generative AI takes in Peter Piper Picta and produces peck of pickled peppers, right? It's creating new stuff that wasn't there before. It's sort of like finishing the thought. Side note, generative AI is predictive AI, actually. It's just that it's like predicting the next thing in the sequence as opposed to predicting the sort of concept of what something might be. But this is how folks refer to it now. Generative AI is the thing that ChatGPT and all these models where you go and you ask it something and like it can write your term paper for you or like do all this stuff for you, right? So like those are generative AI models. You ask them a question and they just spit out a big long answer about something. Or you say, I want a picture of a lion on top of a mountain, and it gives you a picture of a lion on top of a mountain. That's created on the spot and has never been seen before, right? So those are generative AI models. All right. So let's press on. One more thing to say about AI is that artificial intelligence itself doesn't have a very good definition at the moment. 30 years ago, artificial intelligence meant what these days is referred to as artificial general intelligence, which is like the ability to reason and interact with the world. The kind of stuff that you might have thought about like, a while ago was like AI, like, like robots talking to you and like, is that thing really having emotions? Like that kind of thing, right? These days, AI, that's been sort of relegated to artificial general intelligence. These days, AI is more like mathematical models that can predict things and can generate data and so on, right? Okay, so now that we know what an AI is, if we look at that structure, right, here's what I'm going to argue. Anything that we can do to curb what is happening with AI and how it impacts society can be mapped onto this structure. That each piece here is where you want to look to make some rule or some regulation to sort of help put guardrails on things. So we're going to go through each of those pieces now for the rest of the time. Let's look at the inputs first, right? The inputs, this is the data that's coming in, right? So like the age, height, and number of years of basketball, right? That's the data that's coming in. Those are the inputs, pictures of something. That's an input, right? All right. So to think about inputs, I want to go back a little bit, 7 years or so. Does anybody know who that person is? Mark Zuckerberg. Mark Zuckerberg is CEO of Facebook. So this was the first time Mark Zuckerberg, this is the first time Mark Zuckerberg testified before Congress. Actually, it was this testimony which sort of brought me to teaching some of the things that I teach in my class today and sort of got the spark of that idea going. So this was a fascinating testimony before Congress. You can find videos of it online. I would encourage you to do so. There was a lot said. I'm not going to say there wasn't a lot said, but a lot of the conversation boiled down to something like this. Senator Lindsey Graham, and this is paraphrasing, but it's awfully close to exactly what he said. Is Twitter the same as Facebook? And there was a bunch of stuff like this. And half the answers, if you sort of watch the thing, is like Zuckerberg saying, oh, I'll have to have my team follow up with you about something, right? So it really highlighted this gap, this technical gap between folks who are trying to make policy about things and make rules and regulations about things without any sort of understanding about how those things function, almost to the point that it's not even clear what they are to them. And at the same time, the person they're trying to get answers from is a CEO who is not in the thing, right? Who is not creating the stuff at this stage anymore. And so doesn't really have the answers to somebody is like, how do you use this way kind of thing, right? That said, there was a lot here. And so there's a great little NPR summary from back in 2018. But the reason that Mark Zuckerberg was brought before Congress in the first place. So this did two things. First of all, it highlighted this gap between policymakers and technologists. But also the reason that he was here was because there was a scandal that was going on at the time, which was that there was a company overseas called Cambridge Analytica that essentially worked with a third party to scrape the data of Facebook users, data that could be used to sort of profile people in a way that made them more or less susceptible to political advertising. And that company interacted with the Trump campaign back in 2016. And so Congress was like, why did you give your data out to Facebook? And Facebook was like, we did not. And they were like, well, why weren't you more secure with your data? And so on and so forth, right? That kind of thing, back and forth. And so what we're really talking about here are those inputs to the AI model, the data that goes in. And there's a couple of things to think about, well, two broad categories of things to think about for data that goes into AI models. One is, what are we talking about from a legal perspective, and what are we talking about from an ethical perspective? So from a legal perspective, here are some general thoughts, where if you're going to make policy, and I should say right off the bat that AI policy and regulation is just vastly behind the curve in terms of what's happening with AI at the moment. Okay, so it just is. So if you're going to be making policy, here's some of the things that you need to think about. That data that's going into your AI model that is going to be used to make predictions, right? What about privacy concerns for the people from whom that data is being collected, right? Once you collect it, how are you protecting that data? Facebook has a ton of data. I'm just going to use this example, but other examples abound, right? Facebook was collecting a ton of data on people. How were they holding it in such a way, or not holding it in such a way, that allowed other people to go and grab a bunch of personal data from people, right? Consent. So this is something that's come up a lot in Europe, for example, and has started to make its way over to the US through some regulations in various states, which is things like informed consent for when data is going to be taken about you, right? It's like, you're going to use this thing, this website, which is why you see a bunch of cookies, when you go to a website these days, you'll see a little pop-up often that says confirm or reject cookies or something like that, right? That's because this is an informed consent. They're telling you, we are about to collect data on you, right? We're about to put something on your computer that's going to collect data on you, right? So that consent piece might be a regulation that you can add that sort of, that gets at those inputs that might be used in an AI model. Right? Intellectual property. This is a really interesting one that's come about, especially as it relates to things like art and writing, be it creative writing or scholarly writing. So a lot of the models that are built these days use data that's just grabbed from the web. And a lot of that data has intellectual property associated with it. Right. So I'll spoil the punchline a little bit now. If you want to build a model that can recognize what a tree is, you need a lot of pictures of trees, right? And so you might want to go to, say, somebody's Instagram page or something like that who has a lot of pictures of trees and like grab all those so you can use it, right? But those might be Instagram, probably not, but there are cases where intellectual property comes into play, especially in like scholarly writing, for example. So academic papers tend to be the property of the publishers who publish them, right? And so if you're going to go and grab a bunch of academic papers to use to like build AI models that can, do science for you, which we'll talk about, right? How is that okay thing to do? Right? Bias and discrimination law. So those inputs, as we saw a minute ago with the case of using race to predict whether or not somebody's going to default on a mortgage, right? There are anti-discrimination laws on the books that can scope some of how that data gets collected that can then be used in an AI model. Data provenance and accountability. So where does the data come from, right? When somebody who is either building an AI model or has an AI model that they want to pass your data through to make a prediction about something, I don't know, Netflix or Amazon or anything that's making a recommendation uses your data, passes it through a model, and then predicts the thing that you want to watch next, right? So that happens all the time. That's exactly the case of that's exactly our AI model picture that we just looked at, right? So where's that, when they're holding that data, where does that data come from? Keeping a record of how that data was collected, right? So that you can be accountable in the future for if somebody comes knocking and is like, how was my data collected? You can say. On the ethics side, bias, fairness, and representation in data. This is a big one. We're going to get into this a little bit later in just 10 minutes or so. Data ownership and exploitation. So if you collect, and this is still a big open question that's kind of gotten sidestepped, but was really big maybe 10 years ago. If you collect data on me, is that my data or is that your data? Right? You collected it, you have it, but it was on me, so it's about me. So is that mine or is that yours? Right? So data ownership, and then especially exploiting data for purposes that person may not agree with, right? That kind of thing is important for important for consideration when one's thinking about inputs to AI models. Transparency and explainability. Not only is it whose data is it, but what data exactly is being collected. So these days you can go into lots of terms of agreements and stuff like that, right? But I have absolutely no idea all the data that's being collected about me. Zero, right? I can think of some things that surely are being collected, but I don't know everything that's being collected about me, right? So one way that we might start to think about regulating AI as a whole might be to think about, okay, well, how might we make it more transparent what data is being collected for use in these AI models for an individual? Even if it's not for an individual, from the internet, right? Grabbing pictures and scholarly papers from the internet, right? What data is actually being collected? And then this one's interesting. So context and purpose. So there's a lot of thought about, if you just think about the case we're looking at here, where a company scraped a bunch of Facebook users' profiles to essentially feed into AI models that can be used to build political ads that might help a particular candidate. What if the people whose data was being scraped didn't want to help that particular candidate, right? What if the data that's being used about you does harm to another person, right? Those kinds of things. And lastly, we're going to talk about environmental costs a lot later on, or a few minutes later on. But all that is to say is that, like I said, if you want to build a really big AI model, right, you need a lot of pictures of trees. You need, in the cases of things like these chat bots like ChatGPT and things where you can go and ask it questions and stuff like that, these generative AI models, they're trained on big swaths of the internet, which is a lot. They're built with data from big swaths of the internet, and that's very computationally intensive. And as it turns out, that's actually environmentally costly to do, which we'll talk about. Okay, so there's this great quote from Mimi Onuoha, who is a Brooklyn-based artist whose work sort of centers on technology and the way it impacts society, which is that every data set involving people implies subjects and objects, those who collect and those who make up the collected. And it is imperative to remember that on both sides we have human beings, that there's people who are having data collected about them, who that data is meant to represent them who are a holistic person and have rights and thoughts on that data being collected. And on the other side, the people who are doing the collecting, which we'll talk about in a second, every single human being on this planet has biases, intrinsic biases that you can acknowledge, but you can never get away from. They're just there. They always are, good or bad. And so it's important to remember that as data is being collected, ethical norms are different. Societal norms can be different if data is collected across different slices of society and so on. Okay. So that's about inputs, the kinds of things that are going into AI models. But now let's talk about AI models themselves, right? So that's this piece. Well, we'll get to, I'll show the picture in a second, because I also want to take a quick side note as we get into AI models to tell another little short story about another time a CEO testified before Congress. And this was Sundar Pichai, who is the CEO of Google. And he testified before Congress in the same year, 2018, actually. And this one, you can also watch clips from it. It is so funny that there's like little mini videos from like now this politics and stuff to try to make you chuckle. It really highlighted this divide between technologists and policymakers. So this was Representative Poe at the time, who asked Sundar Pichai, he picked up his iPhone made by Apple and said, if I were to move to the left, does Google through this phone that I moved to the left? And he wasn't talking about becoming more liberal or anything like that, moving politically to the left. He meant like getting up and walking over to the left side of the room. To which Google CEO replied, that's an iPhone. So no, unless you put on your location services, right? So if you have location services on, then yes, you're giving some location services to Google. But there was like, even this, something that today would be considered so basic, and 7 years ago would have been so basic as like, this is a device owned by another company with an app on it from this company. And in order for my data to be collected, I need to have location services on. Even something like that was tripping up a representative, let alone any of the sort of like complex stuff that we're talking about here. But speaking of which, there was another funny question that was asked by Representative Lofgren, in which she said, right now, if I Google idiot, and I look under images in Google to see images of what an idiot looks like, she was fed images of the current president of the United States back in 2018. And so the question was, why is that? How does that happen? Right? And that piece, how that happens, is a core, I mean, it was a very innocuous, well, it sounded like an innocuous question, but it was really deep because it's a question about the AI model itself and how does it work? How does it form that association between an input, like the word idiot, and that output, which was a picture of the president at the time, right? So let's talk a little bit about models and how they come to be. So, in particular, how we might think about regulating some of those models. So, turns out that those models, so you can't just like take any neuron off the shelf or any neural network and just like say, okay, here's three numbers. Give me, whether or not Greg can dunk a basketball, right? So that doesn't work that way. I have to like teach it, like you teach a person almost. I have to teach it how to know when somebody's going to be able to dunk a basketball or whether or not somebody's going to default on a mortgage, right? So now, as you can probably imagine, that really complex thing that's in there, it has to, in order to teach it, you have these like knobs that you can turn, right? It's kind of like a little machine that has like a bunch of little dials on it that you can turn. And so if you have those knobs set to a certain setting, what you then do is you pass in some data where you know the answer. You're like, here's a bunch of pictures of trees and pictures of people and pictures of cats and pictures of dogs and pictures of horses and bicycles and airplanes and sunsets or whatever, right? And you know what it is, right? But you're still telling it, tell me what that is, even though I know. Tell me what it is with those knob settings right there. And so the model takes in that data that you hand it. This is called training data. And it spits out a prediction. And it's going to be really, really bad because the model doesn't know anything about trees yet. In a way, you have to tell it about trees and people and cars. And the way you do that is you compare what it predicts to what to be the case. I know this is trees, or I know this is airplanes, or I know this is cars, right? And then you say, okay, let me go in here and start turning the knobs until what it predicts is what I know it to be. That process is called training an AI. When an AI first gets born, it knows nothing about anything, and you have to show it a bunch of stuff. And you tell it, nope, you just told me that's a car, but it's actually a tree. Nope, you said that was a person, it's actually a cat. You said that was a dog, and it's a dog, good job, right? And then you turn those little knobs, and the turning of those knobs sort of turns the AI into something that can then predict to higher accuracy. There's a lot of knobs for models that have billions of neurons in them, but that's the basic idea. There's like a sweet spot where when you get those knobs right, the things that it predicts match the things that you know to be true. Now that's called a trained AI model. That process concludes by then doing the following: taking more data that the model has never seen before. It was not used to train the model, and then sending that through, getting its prediction, and then you compare that and say, how did you do, right? It's kind of like if you have a little kid and you're like, here's pictures of all this different stuff, and then you take them to, and you're like, look at that, and they're like, that's a palm tree, and you're like, yes, right? But if they say, that's a Christmas tree, I mean, maybe palm trees can be Christmas trees sometimes, I don't know. But like, then maybe not so much. But you can get a sense of the accuracy of the model. How good is it going to do when it sees new stuff that it's never seen before, right? So that process is called testing, to test how well it's, to test how smart it is, essentially, how intelligent this artificial intelligence is, okay? And that whole process, showing models data, tuning a bunch of knobs until they give you outputs that match what you know, and then saying, hey, by the way, here's some new stuff, tell me what you think it is, and then testing on that without turning the knobs, that process is called machine learning. Just like encapsulating a semester's worth of stuff into 2 minutes here. But that process is called machine learning. And in AI, so there are many different machine learning models out in the world. And AI is a machine learning model that has been trained and is done learning. And now you're going to use it to do something. That's all that AI is. Okay. So that process, that model process and the model building process, how might we think about it in terms of things like legality and ethics for something like regulation? So in terms of legality, accountability and model governance. So models don't just spring out of thin air, right? People build them. And as people are building these models and turning all these knobs to make predictions about things, right? Somebody's actually doing that. And so if we're thinking about, say, regulating model building, having a sense of accountability, being able to survive what folks have started terming things like AI audits or something like that. How did you do this process, right? What was the data that you used to train on? What was the data you used to test on? How did this thing learn? How'd you turn the knobs? How did you choose what kind of thing to use inside that black box? What kind of neural network to use inside that black box, and so on. Testing and validation requirements. Once you know that, once you have that sort of documented, right? So something like, okay, well, maybe if we're going to have an AI that has like some critical capability, like this is the thing that's going to predict whether or not this person's going to die of cancer. Maybe that testing has to produce results that are really accurate, right? So maybe we want to put regulations around what those testing and validation requirements might be for a given use case. Transparency and explainability. This is really not a thing in the private sector, as you might imagine, because what's inside that box is like intellectual property at the wazoo, right? That's how private sector companies make their money, essentially, right? They put something inside that box that gives them good outputs that they can then use to monetize in some way, right? And so if we talk about something like, what's going on inside that box? Nobody really wants to say, right? And then explainability is really important for people in the public sector, for example, right? Like, and I've had this firsthand experience doing this kind of thing. You know, if I go and I'm working with a public sector partner and I say, I have this AI model that says you should allocate resources over here because this is an underserved community, right? They're going to want to know, how exactly did you come up with that, right? And so I'm going to want to use an AI model that says, well, because this is that, and that is that, and that is that, therefore I say this, right? But based on what I showed you with those neural networks, they're very not explainable. It's hard to know for a given data that comes in how it gets mashed up all along the way as it goes through to give you the thing that you want, right? And so the private sector is much more concerned with getting that accuracy up as high as possible, that testing accuracy up as high as possible, because they want AI models that predict really, really well. You give them a prompt and it generates an output that is exactly what they want to hear, right? It doesn't matter how the model, I mean, to some extent, it doesn't matter how the model works, as long as it works well. That's very dangerous, by the way. Talk about that in a second. Safety and robustness obligations. Talk about that in half a second. So what if you train your model and it's working great and you pass it out in the real world and then something subtly different changes, right? What if you have, I'll give you an example. What if you have a self-driving car and what it does is it has a little camera, so it's constantly taking pictures and it's looking at those pictures and it's like, there's a car, there's a car, there's a person, there's a fire hydrant. And it's like, okay, I need to navigate around all these things, yeah? But then what if like the models of the cars change a little bit, so cars don't quite look exactly the same anymore? So now that model has been trained on something that looks different. Cars from the 80s look different than cars from now, for example, right? Is the model going to perform the same way on the new cars? Because if you showed me a phone from today back in 1980, I wouldn't say that's a phone, right? I was 1 year old at the time, so I probably wouldn't say anything at all, but like, or gibberish, if anything, right? But like in 1985, if you had showed me an iPhone, I'd have been like, that's not a phone, right? And so same thing with an AI model, right? Things will look different. Will it perform the same way? Maybe not. What are the consequences of that? That kind of like data drift, where the thing that you were trained on changes subtly, can then lead to an accuracy in your testing that drops. That can have huge consequences for like disease prediction or for education outcomes or anything, right? So anyway, but this is an area where one might think about in sort of regulating the robustness of models to to changing circumstances. Human oversight and control. So this gets a little bit into like what's called agentic AI. But, basically AI models that go and do things independently, more or less, and learn from what they're doing and get new inputs all the time and try to do new things, right? This sort of concept of human oversight and control, you might want to say regulate that there's always a human who can dip into the thing to make a change, right? So that there's always a human informed process going on in there. Yeah. Some of the ethical things, transparency and reproducibility. So we talked a little bit about transparency. Reproducibility from an ethical standpoint, super important, right? I am a scientist by training. It's like reproducibility is like the scientific method, right? Like if you tell me something's true, if I can't reproduce it or somebody else can't reproduce it, I don't think it's true, right? And so the same kind of thing works with data and AI, right? You're giving me this thing and telling me this to be true, but is it actually true? Somebody else should be able to reproduce that result. Somebody else should be able to reproduce that prediction that your AI model is using. Your AI model is making. Fairness in model design. So I'm not going to get too far into this, but basically how you structure your model and the way that you turn the knobs and things like that can have sort of can lead to outputs that are disparate between different scenarios, different circumstances. And there's a question of like, what is sort of like the societal definition of sort of global fairness kind of thing? And is your model sort of conforming to the expectations of what fairness is given the society in which we live? This goes hand in hand with things like value alignment. And we talked a little bit about this before, which is like, okay, should my model be constrained in a way that it can't do something that I don't want it to do? We're going to see an example of that later, so hold off on that for a second. Epistemic responsibility, right? So like what you say to be true should be true. And I'll give an example. There was a company about 10 years ago, there was a company that did the following. They went to law enforcement agencies in cities and they said, we have this AI model that what we're going to do is we're going to put a little microphone out in a bunch of places in the city. And that microphone is going to record little snippets of sound. And those sounds are going to be the inputs to the AI model. The AI model is going to crunch those numbers from the sound. And the output is going to be, there was or was not a gunshot in that sound, right? So that, police could be sitting there and then you get an alert from the AI. There was a gunshot at this intersection of that, this street and that street intersection, right? And so you go there, right? And as company as it was going around was like, our AI model is 99% accurate, right? Turned out that accuracy was like the accuracy on the training data. And when you showed it new data it had never seen before, it actually did quite poorly. And so this thing was going off all the time with basketballs bouncing on the ground and cars backfiring and all kinds of stuff, right? They eventually fixed it. But like this thing of like what this sort of epistemic responsibility of like, I have partaken in this process and done it in good faith to bring you this AI as it exists today, right? And if I tell you that it's 99% accurate, what does that mean exactly? Right. And again, this one, we're going to talk about this one later. As you can probably imagine, turning these, every time you pass data through, that's energy used by computers. Every time you turn a knob, that's energy used by computers. I'm going to talk about that later. Okay, so some algorithms. And this is going to touch on some of the things that we've talked about, but we're going to go a little bit deeper. So here's a case. This man here came from one day, he got a call and was like, oh, he got a call at work, I believe. And the call was like, come down to the police department and turn yourself in. Like, I don't know what you're talking about. Went home. When he went home, police were there and he was arrested. He was arrested because the claim was that he robbed a jewelry store, right? And what happened was that jewelry store had a CCTV camera. And so the authorities took the images from that, matched that to all the driver's license photos that they had, and was like, that's the guy. Thing was that it wasn't the guy. He wasn't even there, right? So facial recognition. So the root of this, how this kind of thing comes to be is complex. But as we're talking about AI models, the things to really dig deep on is like, when is a model failing? Why is a model failing? And what are the consequences of failure for that model? Some models, might not be super consequential if they fail. Some models might be pivotally consequential. So when is a model failing? So we'll talk about this a little more. But as you can imagine, let's say that you're training up an AI and you're like, here's a bunch of stuff, that I know what it is, right? If you don't show your AI pictures of cars, it's not going to be able to predict what a car is very well, right? So you need a comprehensive set of things the model is going to be expected to do during this period where you're showing it examples of stuff and turning all the knobs. Yeah. If I've never seen a palm tree before and you show it to me, I don't know, big plant, is that actually a tree, right? Those kinds of things. Why is a model failing? So if you don't have that kind of representation in your data, your model can start failing. Your model could also fail because of the kind of model you're using. Maybe your neural network isn't complicated enough. Maybe it's too complicated. That's that architecture piece. And then critically, which we'll talk about in a minute, what do you actually define as success? Because it turns out that that testing piece that I just talked about is not all that matters for success. And then what are the consequences of failure? So this really requires what's called domain knowledge, right? So somebody who's doing the thing that you're making predictions about, right? Who knows, oh, well, it would be extremely unlikely that we are going to have 50 gunshots at Arden Hall right now, right? So possible, but maybe it's just that the basketball game is going on, right? So those kinds of things, having a deep domain knowledge is really important. And that kind of, trying to understand when an AI model fails, what's going to happen, what are the downstream consequences going to be for that? You need like interdisciplinary teams of people. You need tech type people working with people who think about ethics, working with people who think about society, working with people who think about regulation and health and all that kind of stuff, right? Ethicists, important. And it's important to note that in each of these, right, bias, our own individual human bias that infects every person in the world, right, can sort of lead into each step here. And I'm going to talk more about that in a second. So NIST, National Institute of Standards and Technologies, which are the same people who determine like what a kilogram weighs, by the way. They're also tasked with a bunch of stuff related to technology. They did a study on like a bunch of different software that tried to do facial recognition algorithms. And interestingly, they did a couple of different pattern matchings, like is this person that person, or is this person in this group of people, and so like one-to-many and one-to-one kind of things, right? And interestingly, they found that all of them did pretty poorly, but they did systematically worse on faces of color than on white faces. However, that also depended a little bit on where the model came from, who turned the knobs, right? Because they also looked at models that came from Asia, and found that actually they did better on Asian faces than any other subpopulation of people. So it depends a little, right? So it depends a little bit on who's building the model, which we'll talk about more later, right? But lots and lots of algorithms gave very high false positive rates. And that was the case of this gentleman here, being wrongly accused by an algorithm. There's great work on this, which I highly encourage you to look up. Foundational work by authors like Timnit Gebru, Joy Bolamwini, Deb Raji. There's an old paper back from, not that old, 2018, called Gender Shades, that looks at like how different AI models interact with different identities of individuals to give different outcomes and different essentially rates of success. Really, really fascinating stuff. We'll get back more to some of these folks in a minute. I think that minute might be right now. Okay, so here's the thing though, right? We have AI. AI can do amazing things. They took this crappy CCTV camera picture and were like, tried to match it up against, these pictures of driver's licenses, you know? Why didn't they just do like a CSI kind of thing, right? And do like a zoom dance. You go in and now you got the license plate, right? There's an AI giving you a license plate. This is Hollywood. This is impossible. No AI can do this, actually. Okay. I'm going to say this right now. This is an impossible thing to do. Will it be forever impossible? I have some thoughts on how it might not be totally impossible, but no, you can't do zoom enhance right now. But that's not to say that people aren't trying. So there was this case a few years ago that was put out on a web called Pulse. So what is a little bit of technical speak here for a minute, but that process of taking a low resolution picture, passing it through an AI, so your input is a low resolution picture, you pass it through the box and your output is a high resolution version of that. That's something called super resolution, doesn't really matter. But that's exactly what they were trying to build, a zoom enhance kind of thing, right? And so we had, this is, if I can get it to go. This is how it works. You have a low resolution picture. You're trying to like make a face that's the high resolution version. You downsample, you compare the two. You're doing your sort of like training here. I know this is what it is, right? So, and in the end, you have a picture that kind of like matches your input. Right? So you're like, that's what the picture of the person would look like if it was high resolution and not low resolution, right? Cool. So people tried to use this example. Who's that? Barack Obama. And they said, okay, zoom enhance. And they get that. Not so good. Okay, so what about some other examples? So there was somebody on Twitter at the time who was like, here's and that's what Pulse thinks I look like. That's AOC. That's what it thinks she looks like, right? This was the tweeter's wife, who was of Asian descent. That's actor Lucy Liu on the bottom, right? So this was what became known as the white Obama problem for a while, which is that this model was taking every face, no matter what you put in it, and spitting out a white person, right? Again, this is called algorithmic bias. And again, the questions to ask are, when is a model failing? Why is a model failing? And what are the consequences of failure? And this ignited a really big sort of back and forth on Twitter. In the before times in Twitter, Twitter was actually kind of interesting. And there was like science Twitter, which was actually like, it's actually kind of interesting. Like there were a bunch of folks having like deep conversations about science that fun times died quickly on Twitter. But this ignited a conversation between some of the luminaries in the field of artificial tech, like the technical side of artificial intelligence, right? Like the folks who like constructed those neural network type models, the earliest neural networks to do all kinds of amazing things that nobody thought could happen before. And AI ethicists, folks who are at like the forefront, some of whom I just listed up there, AI ethicists, on what went wrong here. And this was fascinating because it was almost as if the technologists like couldn't grasp the issue, because the technical answer is, like I just told you, the model was trained on mostly white faces. And so if it sees a face of color, it's just not going to do a very good job. It's going to like default to what it knows, basically, right? And that's technically true. But that's not the question. That's not the problem of what went wrong here. So yeah, you go in and you train the thing with more faces of color. Fine. The problem is, why did nobody notice this? How was this termed to be a good model in the first place? And it's almost like that concept couldn't be really understood by some folks who were having the conversation. It's like, why wasn't this thing tested before being pushed out to the public? Because there was clearly an intrinsic bias of the folks who built the model, because they didn't even occur to them that this kind of thing should be tested, right? Right. So what do we mean by a good AI model? All right. So this was, let me give you another example of AI models and some of this ethics stuff. So this is from my own work, actually. I'm going to speed up a little bit here. This is from my own work, actually. There's no ethics involved here. We took a bunch of trash data, like when trash was collected in New York City in various districts, and we built an AI model that predicted how much trash would be would be produced in like a week or something like that, right? And we were talking with Department of Sanitation about like, can we use this to like optimally route trucks to go places? There's like this whole like resource distribution question in public administration, which is like, can you use data to more optimally deploy resources? Do you have to have your inspectors go to every building for fire inspections, or are there some buildings that are more likely to fail a fire inspection for one reason or another? Build an AI model. There was a group in Pittsburgh that did that a while back at Carnegie Mellon, right? But so there's this like broad class of like how you allocate resources and can you use data to allocate resources, and that's all well and good for trash. Not so great if you want to send police someplace. So there's something called predictive policing, which essentially inputs are how many citations and arrests have been made in an area. AI model. Output is how many police are needed in that area in general, right? As has been shown, for example, by the Department of Justice itself, predictive policing programs don't work at all, right? And because there's a bias, which is maybe a little bit hard to see, but that bias is thinking that your inputs are actually the thing that you want to be measuring at all. Because if the thing you're trying to predict is crime, because that's where you want to send police, turns out that things like citations and arrests are not actually where crime is happening. It's where police are interacting with people. And there's a history in the United States of police interacting with people of color and neighborhoods with high density of population of people of color, and therefore you just get more citations there, and so the model just sends police there, and so there's this bias that then gets pushed out into perpetuating further a bias. After all, if I walk outside and smash a window, the crime has been committed, but if there's nobody to see me, I'm getting arrested, right? Yeah. Okay. So that's going to bring us to AI outputs. And I thought a lot about how to do this part, like how to talk about AI outputs in the context of regulation. And after thinking about it for a long time, I came to the realization that it's impossible. And the reason that it's impossible is because AI does a lot of stuff. And if you're going to talk about regulating the outputs of an AI model, well, that's going to depend on exactly what it's trying to do in the first place. So I went to an AI, I went to ChatGPT, and I asked it, for these outputs, give me 100 examples of AI outputs, both predictive and generative use cases. And there's 100 different things from which AI is in all of those things. So pick your favorite thing. I mean, I could have probably asked for 1,000, but pick your favorite thing. Yeah, environment and climate, deforestation detection from satellite imagery. So inputs are basically satellite images that are pointed down at the surface of the earth. Output is like the prediction of how much deforestation has happened compared to previous satellite images, right? So there's an AI in there that's doing that, that's sort of parsing those images for that. Disease diagnosis from X-rays or MRIs. Yeah, you hand a picture of a potentially broken bone. Sometimes AI models can be more adept at figuring out whether or not there's an issue than an actual doctor is. So there was an amazing, I don't have a slide of it here, but there was an amazing paper, one of the sort of like early, like back 2016 or something like that, cases where an AI model was fed a bunch of pictures of moles on people's skin, right? And the output is cancerous. And so they trained up this model because they knew whether or not these pictures were cancerous. And then they were like, okay, here's what the AI model predicts, and asked dermatologists. And the AI model did better than some of the dermatologists at predicting whether or not a mole was cancerous, right? There was just something about it that the humans couldn't see, but that the AI could see. There was something unique about it that we just don't know what it is yet, right? Fine. Let's see. Career path recommendation engines. It's like Netflix for your career. Essay grading automation. There's one. So I sometimes get essay. I don't assign a lot of essays these days, mostly because there's really no point, which we'll talk about in a second. But like I, as a professor, could like go to an AI, Chat GPT in this case, and be like, grade these 10 papers. And here's my rubric of what I think should be how I think things should be graded. Grade these papers. And it will do that. I mean, I hate to say it, but it can do a pretty good job at that, actually. So there are so many outputs. And I think when we talk about regulation from the output side of AI, I still think this story sort of holds up, that regulation has to be mapped to those sort of three pieces of AI, those inputs, models, and outputs. But when we talk about output regulation, there's so much there, it has to be linked with specific use cases. And so this is why it gets so hard to regulate some of this stuff, because it just slips through your fingers. You regulate one thing and then another use case in the very same domain is slightly different enough that it's just different, right? But here's all ways AI is being used. All right. Addressing the technical gap, that gap between people and between policymakers and technologists. How to actually do this, how to actually regulate. There have been a handful of efforts at regulation over the past few years, especially in Europe, but also in the United States. And a big one was an executive order by President Biden a couple of years back in 2023. That was an executive order on safe, secure, and trustworthy development and use of artificial intelligence. It is, after this talk, it should be very readable if you're going to go in and read it. But what I'm going to show now is, I think one could take this document, and even though it wasn't constructed that way, it reads a little haphazard, kind of all over the place. But I think you can map it directly to those pieces, that sort of picture of the AI we saw. For example, let me just start off by saying there was some great stuff in here in the beginning, at least in my opinion, right? So my administration cannot and will not tolerate the use of AI to disadvantage those who are already too often denied equal opportunity and justice. From hiring to housing to healthcare, we have seen that what happens when AI use deepens discrimination and bias rather than improving quality of life. Artificial intelligence systems deployed irresponsibly have reproduced and intensified existing inequities, caused new types of harmful discrimination, and exacerbated online and physical harms. There's other stuff inside of here that sort of goes on from there. So I encourage you to read it if it moves you. Okay, so let's talk about AI and how this document, actually does map directly to this model. So input data. So here's an example, right? So, within 90 days of this order, HHS shall do blah, 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 identify appropriate guidance and resources to promote the deployment, including in the following areas. Incorporation of equity principles in AI-enabled technologies used in healthcare human services sector, using disaggregated data on affected populations and representative population data sets when developing new models, monitoring algorithm performance against discrimination, so on and so forth. So that's talking about that input data. What kind of input data can you use? And how does, say, taking aggregated data where you say the average height in this room is, 5'8", versus disaggregated where I have each and every individual person's height, right? How do those models change when you start to do that? That input data starts to get more and more personal, right? Here's another one. Housing development should look at how including the use of data such as criminal records, eviction records, and credit information can lead to discriminatory violation of federal law in terms of housing outcomes. So that's speaking about the input side of things. Right? Then we get to the model side. So for the purpose of what it's saying right here, you can think of the word weights as knobs. They're termed weights, but it's basically those little knobs that we turned before, right? So amazingly, this was amazing. Executive order, the ownership and possession of those knob values of any AI model and the physical and cybersecurity measures taken to protect those knob values, right? So this is actually addressing like how the model was tuned up to give you what you wanted, right? And those knob values, like how you set the thing, that's really important because that kind of information, depending on what your model's doing, falling into the wrong hands can be disastrous. Talk about that in a second, right? So it's actually directly addressing models themselves. And then finally, outputs. There's a bunch of output stuff in here, right? So a description of any associated measure a company who's building an AI model has taken to meet safety objectives. The description has to include things like, has that company conducted red team testing, which is sort of trying to make the AI model do something that you don't want it to do, right? That lowers the barrier to entry for the development of biological weapons. So basically, what this is saying is like, if you're developing an AI model like ChatGPT, you better have somebody testing whether or not that's going to tell you how to make a biological weapon. That's an output, right? Here's another one about societal norms. No AI can produce images of child sexual abuse material or non-consensual intimate imagery, deep fakes, essentially, so fake pictures of people in intimate circumstances. These are outputs. These are regulations of outputs. All right. So I want to end here with just a couple minutes on downstream effects. Okay. So like what's here now, what's coming, those kinds of things. And I'll be quick about this. It's basically going to be a bunch of things you may have heard of or may not have heard of in the news that are kind of interesting. So, you know, when you build AI models, you have to write a bunch of computer code. I've kind of talked about it in a very qualitative sense here, but at the end of the day, there's a lot of computer code that you have to write to like make an AI model, just the way it is. You have to like actually like write computer code that puts that neural network together, for example, and then trains the neural network to give it the outputs that you want, those kinds of things, right? A lot of these models are built on computer chips that are made by a company called NVIDIA. And the CEO of NVIDIA said that basically generative AI, like I asked it to give me 100 use cases of AI. Here's something amazing. I could go and I could say, write me a computer code to build an AI. And it will write me a computer code to build AI. Something that would take a human weeks to do can be done in a blink of an eye now with sort of modern AI tools. So does that mean all the coders are going to go away and that new AI tools are going to be like, somebody's going to stand there and say like, write this AI tool to the AI and it's going to write the AI tool, right? And the person who actually does that, is that job going to go away? There's a broader question actually about jobs, which has been brought up by a bunch of politicians, but this one was most recent. It was Bernie Sanders a couple of weeks ago, maybe even a week ago, right? There's a real question about whether, you know, automation had a big impact on people's jobs in the United States. There's a big question about whether automation combined with like AI level reasoning, which is not quite at human level reasoning yet, but like AI level reasoning, is that going to eliminate a bunch of jobs, right? If it eliminates 1 million jobs, there are those million people with jobs now. And people keep talking about like, and even most recent administration, the Biden administration talked about like jobs of the future and like modern jobs and high-tech jobs and so on and so forth. What if the high-tech jobs are disappearing? What jobs exactly are there going to be, right? That question has come up quite a bit, actually. It has come up for artists, right? So how will generative AI, which can just, you know, you say, I want a picture of a lion on a hill, right? And that's very, you know, gives you a picture of a lion on a hill. That's like I encourage you to like go to the internet and ask like, you know, show me some generated AI art. There's amazing stuff out there that's totally just completely generated, made up by AI, not made up by people. And it's being used by companies in place of people. The amazing thing is, I'm pretty sure that picture right there is AI generated, which is kind of funny. There's aspects of that which make me think it's clearly AI generated. But there's a great quote in here, which is like, how will the roles of artists and designers change? All right, so how are they going to stay the same? Yeah, they're going to continue to be responsible for bringing creative visions, concepts, and ideas in the world, infusing them with meaning and blah, 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 blah. Nevertheless, they are likely to see their roles change with a focus shifting towards providing creative direction, conceptualization, and critical thinking. Translation, AI, give me a picture of a lion on a mountain, as opposed to me drawing a picture of a lion on a mountain, right? Right. So you can think through consequences for things like animated movies and things like that, right? Where animators may not even need to exist anymore at some point. Here's a video. I'll see if I can get it to play. I'll put the microphone on it. If not, my apologies, but I think you'll get the general gist.
3 seasons and a podcast, bragging about getting gigs and battling a villain. Meet the latest creation from the world of artificial intelligence.
Tilly Norwood, 100% AI generated.
The European company Particle 6 is presenting her as an actress. The CEO says she's been meeting with entertainment companies, and Norwood could be represented by a talent agency in the next few months. Real-life actors are...
Right, so that's not a real person. That is generative AI creating a person, to which talent agencies are now looking as like maybe part of the future, if not all of the future. It's a lot cheaper to ask an AI to make a movie than to actually go make a movie. Right? Now you can kind of tell they look like it's kind of, that might be AI generated. But a year ago, you'd look at an AI movie and it would be like 10 seconds long, and like, there'd be like arms coming out of people's heads and stuff because you just can't do it. The amount of progress in 1 year, 2 years has been amazing. Think 5 years, 10 years. Will movies still need to be made? I don't know. Need is a question. Right, so here's another one. Oh, I can't watch it remotely. Okay, so let me just go back and let me tell you. Basically, there's like a whole bunch of things, like are these breaking news things where there's music or they're telling you something like, actually, I'm not real, right? And a spaceship comes out of the ocean or something like that, right? And so, yes, this is all very funny, but there's a real question in the future. How do you determine what's actually true, right? How do we know what is actually truth? Just a week ago, there was a video put out of the Minority Leader Schumer, not even a week ago, a few days ago, Minority Leader Schumer by Senate Republicans that was completely AI generated, saying how good the shutdown is for them, for Democrats, basically, right? And so, the word had to be put out that was actually fake, right? But it looked very, very real. These things look extremely real. So in the future, how do we know what true actually is anymore? Right? That gets to be very hard. What's the corroborating evidence you need to have so that you don't know that you can say I wasn't actually there robbing a bank or something like that, right? Yeah. Oh, that worked. Hold on 1 second. Let me see if I can get it again.
These AI-generated news anchors are fooling the internet. An increasing number of videos presented by AI-generated news anchors are going viral across social media. Although the anchors may appear legitimate, in reality they are reporting on events which never actually happened. Angela Carter here, live from the Cedar Grove flood disaster. Just kidding, I'm not real. While many online users...
Right, so there's a few more. In the interest of time, I'll keep going. So there's a few more. You can check them out. Some of them are, but some like so switched. The British politician switched to his party last week, and that person had to put a disclaimer saying that didn't actually change parties, right? Like that's not true, right? So. Now we talked a little bit about writing, and there's whole like death of the essay thing, right? So I'll tell you that certainly in my classes, and I think in most classes, we're getting close to 100% of content that gets turned in as AI generated. It's not exactly 100%, and it varies from student to student, class to class for things, but even like technical classes that deal with like physics or computer coding or whatever, it's almost all AI generated content. There's a lot of AI generated content. Certainly when it comes to essays, I'm confident in saying that 99% of like writing that happens in universities by students these days is, if not just directly AI outputs, generative AI outputs, is essentially modified versions of AI outputs. I use AI myself to write things sometimes, modify things, right? Absolutely. So what happens now? How do you grade that? How do you assess whether or not somebody knows the thing they're talking about, right? What does it mean to know something? But is it really the essay that's the problem? I don't think it is, actually. I think that eventually we're not going to have human-generated writing anymore for things that are not essentially creative, right? So why have a newsroom with somebody typing up a news story when you can give the basic skeleton of the facts to an generative AI model and a news story for you? That's what Sports Illustrated did and got some flack for that. But this was a while back. This is going to become normative for sure over time, right? So when you're reading a news story online, it may or may not be a person who actually wrote that news story. Right. Last thing I want to talk about is AI and the environment. Here's an amazing fact for you. So data centers, it's like hold all of those inputs, that turn all of those knobs, right? Those are a lot of electricity, so much so that at the end of 2023, data centers are the largest electricity consumer between Saudi Arabia and France. And by 2026, next year, that's going to bump to be the fifth between Japan and Russia. How do you make that much energy? Well, I'll tell you one thing that happens is that folks who provide AI models are starting to look towards nuclear power. Microsoft bought 3 Mile Island for this purpose. There are little reactors that are being created and built by companies who want to use them to power data centers for AI models and so on and so forth. And there's a question about where are these data centers exactly going to go? How efficient are they going to be? How are they going to impact local populations? The electricity consumed, brownouts and blackouts. There's a lot of water that you need to cool these computers because they get super hot. What about water supply issues? What if you put a data center in an already water-starved location? And so on and so forth. The environmental impacts are quite big. In fact, there is a proposed data center down in Delaware City. And there's a news story here that you can go read. There's been a number of sort of interactions between the residents and the proposers of the site. And I'll just end on this great quote from a resident, Ike Brown, that within 4 miles of a refinery, moving traffic noise from airplanes and helicopters. My moral and ethical question is, who has the right to decide the impact on our health and quality of life other than the people who actually live in these communities? And so I'll stop there. Happy to take any questions. I know we're a little bit over time, but happy to take any questions. Yeah.
Environmental issues.
Yep.
Didn't get to as much sort of the idea of how to regulate this and
Yeah.
the role of government could be in.
Yep.
So I'm wondering, a lot of the talks of regulation have to do with regulating the models, the actual content and function of the AI. I'm
Yeah.
wondering if there are ways to physically regulate the AI.
Yep.
Both in terms of sort of power requirements. Another example I use is a lot of times in the old phone systems, phones have gone from being very dumb with a central switchboard to now they're completely distributed and the central towers are dumb. Is there any chance that on-chip model will get to a point where we don't need giant data centers anymore?
Right. So maybe. So efficiency of AI models is also increasing. That's definitely true. Right now, the pace is not going that way. So there's a lot in that question. So the first part about physical control, yes, absolutely. You could regulate and say like, no, you can't make a data center bigger than this, or you can't put this many data centers in this area, or so on and so forth, right? I would say there's almost no appetite for that in government at the moment for a variety of reasons. One is economic growth questions and the extent to which AI is tied to economic growth. Another is, I didn't talk about it here, but like winning the arms race of AI with our geopolitical rivals. And, there's a question about, who's going to get to what place first. I didn't talk about AI use in national defense either, right? But there's that question too. I urge you to look up how effective AI is at piloting fighter jets compared to fighter jet pilots, for example. But then the question of like, is this environmental impact always going to be this way? Or are things going to get more efficient, essentially? And I think there's two things in competition. One is the ideas of what folks want to do with AI is grand and gets grander all the time. And the other one is that the efficiency is going up all the time. So which one of those is going to win out? Because the grander it is, the more bigger models you need, and so on and so forth. I'm not sure. What I do think is going to happen, though, what most sort of folks who think about the technology in AI is that there may be like a paradigm shift in the way AI works. So people have been pushing on these neural network models. And like I said, they're not the only models, but they're by far the most commonly used in AI applications. Been pushing these neural network models since the 80s, really. That's when we started having enough data, enough computing power to actually turn all the knobs, to actually give you good outputs. Before that, from like 1950 to 1980, there's like, you know, you couldn't store enough data on a disk to train the model. You couldn't have enough computer power to train the model, so on. But then eventually we had that sort of revolution where we could do that. But now people have been using neural networks from the 80s to now. There's a question about whether or not we've sort of hit a conceptual wall with how good those models can do for things. It may be that there's going to be somebody's going to come out with like a model that's super efficient and also really great. There was a model that came out of there was a neural network model that came out called DeepSeek that came out of China that purported to be able to do and purports to be able to do as well as all of the sort of generative AI models that we have here, but that used many times less essentially processing time to turn all the knobs. And so, it was much more energy efficient, right? So yeah, we'll have to see, but I think we probably need a paradigm shift before we get away from this kind of thing. Yeah. Oh. Question. Okay. Oh, sorry. I'll repeat the question. I'll repeat the question. Wow. The question was, because I am personally in this, do I think that the human race has essentially the moral ethical strength to get out of everything that might happen? That is a hard question. I'm going to dodge the question a little bit by instead telling you the things that concern me. So, I mean, we're going to have to make changes in society for some of the stuff that is happening now. It's definitely happening in academia, and it's happening in society right now. There's been recent studies showing that using AI changes the way people's brains function. That's absolutely, I mean, that has been reported scientifically. That's not just people talking. There's actually like brain scans of people who use generative AI to do things versus people who try to think through writing something, right? Fine. But the things that concern me, I mean, that's maybe concerning. It depends on how you think society should evolve. I don't know. The things that concern me, I mean, how folks respond to things morally and ethically is difficult. Part of the problem is that everybody has different morals and ethics, which is maybe good, which is good. But there are some use cases that I think might be a little concerning. Not now, but in the far future, okay? So one of the things that folks are trying to do with AI, and maybe this is because of my background, I don't know. One of the things that folks are trying to do AI is they're trying to do physics with AI. What do I mean by that? I mean that folks are trying to train AI models to essentially like learn physical concepts, like the laws that govern the physical universe, right? To like learn about those and even kind of push on those a little bit to try to do like, because there's been like drug discovery in biology, so like using AI to try to create new drugs that might be useful, which has had mixed success. There's like AI for creative pursuits and push on the boundaries of that for sure, right? And there's also been AI to push on some of the boundaries of like physics kinds of stuff, right? Now, I would argue that what has given humans, what has made us the sort of dominant species on the planet for the past many thousands of years, has been our understanding of the physical world, right? And how to use that physical world to our advantage. Which is not to say that all of a sudden AIs are all going to turn on us and it's going to be the Terminator or something. But it is a little bit disconcerting to think that you might have a model that maybe understands the physical world better than you do, right? Kind of think of it like the example of like the mole being cancerous and like maybe it's better than some doctors at that, right? But like, what if the AI understood how to like put molecules together to create energy in a way that was understood is not really a good word, but it's a euphemism, right? Could predict about how to put molecules together and produce energy in a more efficient way or something like that, right? We could harness that for sure, but it is a little bit disconcerting to think that that kind of thing could be encoded in something that is maybe not totally under our control, or maybe it has other forces that are acting upon it. I do worry about politics and sort of the geopolitical situation and how that intersects with the AI arms race. Folks talk about AI consciousness. I don't think we're there, but at some point it would be very difficult to distinguish between a conscious AI and a non-conscious AI. So I don't know. I don't know. It depends what you mean by get out of it. I don't think we're ever going back. I think that's the thing. I think humans have caught the AI bug the way that humans caught the combustion engine bug. Once you get in the car and you get from here to there in 10 minutes instead of 2 days, you're not going back. Once you're able to like do all this stuff, once you're able to like write college essays, right? Those kinds of things, you're not going back, right? It's the efficiency is too high and everything else seems too slow. So how do we navigate that moving forward? Very difficult. Other questions? Yep.
Rewiring the brain. What comes to mind for me is Planet of the Apes. That in 1,000 years, people have become dumber.
Yeah.
I feel dumber. I can create arguments for a thought.
Yeah.
And I don't have to reread my notes over and over. I mean, it just does.
Yep.
Work.
Yep.
And it will condense it down to whatever size I want. I have to separately.
Yep.
But I've spent a lifetime learning, so
Yep.
I'm more concerned about your students that haven't yet learned how to learn.
Yeah. So the question for folks online, question is on the statement a few minutes ago that changes the way our brains work, and what are going to be the long-term consequences of that, essentially, if I paraphrase. Are we going to get dumber, right? Are we just going to get sequentially and successively dumber over time? You know, I don't, that's a good question. I don't know. I don't. So there are some things that generative AI still cannot do. Critical thinking kinds of things that it's just not great at. It's getting a lot better at them, but it's still not great at doing some critical thinking tasks. And in fact, those critical thinking tasks, I would argue, are like the most important thing for human learning. Critical thinking is the thing that lets you learn about a given subject, lets you make hypotheses and comparisons, even if you're not phrasing them as hypotheses and comparisons. Even if you're like, I don't know, if you're doing physics or math and you're using hypotheses and comparisons to learn about, though, if this is true, that should be true. Or if you're painting a painting and you're like, given these two colors, I'm going to be able to evoke this if I combine this way, right? There's this critical thinking aspect to everything that kind of involves learning. And this is my opinion, that involves learning, that I think AIs are not really quite there yet. And so as an educator, like I said, I've stopped giving my students sort of long form essay type things. They write computer code in my classes, and I don't really grade them on the writing of the computer code anymore. because they can just get an AI to write computer code for them. Rather, what I try to do is I try to give them assignments and talk through assignments with them that sort of say, okay, why is this the way it is? And if this was this way, what would that mean for that over there, kind of thing, right? So that they can navigate, so that when they get spit out something by AI, they're not just like copy paste. You know, there's a great quote by a professor, I think it was at Brown University, who was like, at the moment, AI produces B- work. And I think that's basically true. In my experience, it's basically true. Like you can go to generative AI, ask it to write you an essay, copy and paste it. And then if it gets graded, it's kind of like a B- essay. That won't always be true. In fact, one of the things that frustrates me most is when my colleagues say like, oh, I can totally tell when something's written by AI. That's great. But if I had given you something written by AI a year ago, you'd be like, this is like first grade writing. Well, not a year ago, but a few years ago, you'd be like, this was written by a first grader, right? You could barely string a sentence together. Now you can like write whatever you want, right? You can write whole books with AI easily. So 10 years from now, you won't be able to tell what was written by AI and what wasn't. And so you have to figure out how to teach folks to learn about things is something that is critically important for education going forward. Absolutely. Absolutely fantastic question. Can you use it to detect whether or not AI has been used? The answer is kind of, but not really. So this has a little bit of a history. There are a type of neural network called GAN, G-A-N, stands for General Adversarial Network. The basic idea there is that you're actually training two little AIs next to each other. One that's learning to output something, and the other one that's learning to output whether or not that thing that it's telling you is true or not, right? And it's trying to create examples that trick the previous one, right? So that way you actually build stronger AIs in the end because they're like fighting against each other, right? So that generative, adversarial, those adversarial networks eventually grew into these days are used in a context where like there are these AI detectors. And yes, we have those tools available to us as educators. You can like take an essay that a student wrote and put it in a thing and say, was this written by AI? And it'll be like 75% chance this was written by AI. Well, what do you do with that? Right? You can't fail a student because of that, right? And even if it was 100% chance, can you really use that as a predicate to essentially have a penalty against somebody? So, I'm on a faculty senate committee at the University of Delaware looking at AI use at the university. And one of the things that we've talked about is like how to provide guidance for instructors on like the future of this kind of thing, because there's no use in trying to fight back the ocean. This is it, right? This is going to happen, whether or not you like it or not. You tell your students not to use AI in the classroom, they're going to do it anyway, and you're not going to know about it, right? So what's the point, you know? And these AI, these sort of adversarial things that try to detect whether or not something is AI, in some cases, they're really good for certain topics, like in cybersecurity or like fraud detection or something, or bot detection on social media. They can be really good for that kind of thing. But for determining whether or not like something was written entirely by AI, it's very, very difficult. They're better on images right now, but text is this, you get a probabilistic estimate out of it, and that probability may be in a value where you can't make a decision. It's not actionable. Yes.
The Biden executive order that you referenced was unordered on the first day of presidency. Anything positive happening now in the government that's going to help us with any of it?
Do I see anything positive happening now in the government? I'm not positive. I think it's being thought about a lot. So the current administration is thinking about things a lot. And I do think there are people in the administration that recognize, I think there has been a growing bipartisan recognition that this is not only can't be ignored, for a long time it was being ignored, but that it's already changing society. And our global competitors also are experiencing the same thing. And so we need to make sure that we are ahead of the game. Now, I do think my own personal opinion is that recent moves have stepped us backwards on that front. Certainly as an academic, when I see the kinds of things coming out of some of our global competitors, I say, they're eating our lunch. But then I see other things coming out of the United States where I'm like, wow, that's way better. I think the DeepSeek thing, which was this Chinese, essentially not really competitor, but kind of competitor to like ChatGPT and Gemini, which are the big generative AIs in the United States. Like when that came out, people were like, whoa, you could actually do this for a lot cheaper maybe. And so how are they actually doing this kind of thing, right? And there was like a moment of where it was like, okay, that was the thing we're supposed to be really good at, right? And now this is happening. So what's going on here exactly? Yeah. Okay.
Go on, or you'll have to come back.
I could keep talking. All right. Well, thanks, everybody.